Okay, welcome back, welcome back. All right, so this is the part 2 of scale drawing. Just to give a little recap about scale drawing, the first video we discussed that scale drawing is a diagram, a map, a model of an object that is too large or too small to draw, and we said that the dimensions of it, meaning the length and the width of the object to the actual dimension or the distance of the real life example, real life. So we said that examples of scale drawing would be like maps, blueprint, a floor model, sketching maybe a car, and so on, etc. Alright, so those are some examples of scale drawing. So let's continue with scale drawing. So we're going to work some more questions. These are somewhat different from the first video. So let's get right into it. Okay? Alright. First question that I want to look at. It says, a science textbook uses a scale of 3 centimeters equal 2 millimeters for drawings of small insects. It says, what is the actual length of a flea if the drawing is 7.5 centimeters long? Whenever you're given a question, the first thing you need to do is to try to understand what the question is asking you to solve, or what is it asking you to find. Alright? That's the first thing that you must ensure you identify. You have to identify the key components of that question. So we're going to go through the question and identify the key components by either underlining or circling the key components. Alright? So let's go. It says a science textbook uses a scale of 3 centimeters to 2 millimeters. So the scale is given, which is 3 centimeters equal 2 millimeters for drawings of small insects. The question now says, what is the actual length? What is the actual length? What is the actual length of a flea if the drawing is 7.5 centimeters long? So those are the key things about it. Alright, so remember, whenever we are solving scale drawing, we always use the scale length over the actual length. Alright? So we have to always remember it is the scale length over the actual length. Alright, so let's get into it, solving this problem. The scale that is given in the question, the first thing that we are going to do is to set this scale as a ratio in the fraction form. By the first term will go in the numerator of the fraction. The second term will go in the denominator of the fraction. Alright? So 3 centimeters, that's the first term in our numerator. So that is the scale length. 2 millimeters, go in the denominator, that's our actual. So the first term is always the scale, second term is always the actual when given a scale. Alright? Alright. So it is given that the drawing is 7.5 centimeters long. The drawing is 7.5 centimeters long. When we hear the term drawing on a map, in the model, we know that it's telling us that's the scale. Right? So 7.5 is the scale length. So after writing the scale that is given as a fraction, we are going to write it as a proportion. So we're going to set it as a proportion by 7.5 centimeter. We said that's the scale, and remember, scale always go into the numerator. So 7.5 will go in the numerator, and we want to find the actual that goes in the denominator. We know that's going to be millimeters. So we use a letter for the unknown that we want to find. Alright? After we set the problem or write the problem as a proportion, next step for us to do is to cross multiply. 3, we're going to do 3 multiplied by x, and we're going to do 2 multiplied by 7.5. 3 multiplied by x, that's going to give me 3x. 2 multiplied by 7.5, that's going to give me 15. Now we have 3x is equal to 15. We know that 3 of the x is equal to 15, but we want to know what 1 of the x is equal to. Once the coefficient of the unknown, the coefficient of the letter, the coefficient of the variable, in this question, x is our unknown, x is our variable. Once the coefficient, that's the number that comes before it, is not 1, we have to divide by that number. Alright? For it to become 1. Remember, any number we divide by itself is 1. 100 divided by 100, 1. A million divided by a million, 1. 2 divided by 2 is 1. Alright? So, we divide by 3 for the coefficient of the unknown to become 1. So we want to know what 1 of the x is equal to. Anything we do to one side of the equation, or anything we do to one side of the equal sign, we also have to do the same thing to the other side. So we divide both sides by 3. 3 into itself, 1. 3 into 3, 1. 3 into itself, 1. 3 into 15 goes 5 times. We're left with x is equal to 5. X is equal to 5. And the units, remember, we must write our units at all times. So unit will be 5 millimeters. Alright, let's continue. We have a second question. What you can do to see if you really understand, you can pause the video and work the problem, and then you can continue watching the video and then see if you get the same result as I have after working the problem. Alright, let's go. So remember, read the question, try to understand the question. So the question says, a blueprint was used in a scale of 3 centimeters equal 4.5 meters. Find the actual length of it. Length if it is 5 centimeters on the drawing. So find the actual length if it is 5 centimeters on the drawing. Whenever we have a question, first thing we need to do is to find out what is it asking us to find, what is it asking us to do. Alright? So let's go through circular key information, important information in the question. So it says a blueprint was used in a scale of 3 centimeters equal 4.5 meters. That's the scale we're using, alright? It says find the actual length. That's the question. Find the actual length. If 5 centimeters on the drawing. So if it is 5 centimeters on the drawing, what is this telling us? This is saying every 3 centimeters, it is actually, on the drawing, is actually 4.5 meters in real life. So This is saying 5 centimeter on the drawing. We want to find what is it in real life. Remember, once we're solving, it is always the scale over the actual length. So scale length over actual length. Scale length over actual length. First step, the scale that is given, we're going to write it as a ratio in the fraction form. So the first term in the scale, that's going to be our scale length, so that goes in the numerator, centimeter. Second term goes in the denominator, so that's 4.5 meters. Right? Alright, so after writing the scale as a ratio in the fraction form, the next information that is given in the question is 5 centimeter. Since it says on the drawing, once we hear the term or the phrase on the drawing, on a map, in the model, we know that's the scale length. Alright? So 5 centimeter here is the scale length, and scale always go in the numerator. So we are going to say equal to 5 centimeter. We want to find the actual, so that's the unknown. Our answer is going to be in meters. So that's going to be 5 meters, alright? That's going to be x meters. The unknown is going to be x meters, sorry. Whenever you set the proportion, to know that we set the proportion properly, centimeters in the numerator on this side, centimeter has to be in the numerator on that side. Meters in the denominator on this side, meter has to be the denominator on that side. So the same units has to be in the same position. Alright? Alright, so next step, we cross multiply. 3 multiplied by x. Setting it as the equal 4.5 multiplied by 5. Alright? 3 multiplied by x, we know that's going to give us 3x. 4.5 multiplied by 5, that's going to give us 22.5. Remember, the aim is to find what x is equal to. Aim is to find what x is equal to. So to find what x is equal to, once the coefficient of the unknown is not 1, we divide by that coefficient to get the coefficient to become 1. So we're going to divide both sides by 3. Anything you do to one side, you have to do to the other side. That is why we divide both sides by 3. 3 into itself, 1. 3 into 3, 1. 3 into itself, 1. And 3 into 22.5, that's going to give me 7.5. We're only left with x on this side, and we're left with 7.5 on that side, and our answer is in meters. Don't forget to write your units. I hope you did pause the video and you work the problem and we're getting the same answer. So if you're not getting 7.5, you made an error somewhere. So look at the question, look at the answer and see where you made your error. Alright? We're going to work another question, just to reinforce so we can have better understanding of how to solve scale drawing. Alright? Alright, example 3. You can do the same thing. You can pause the video, work the problem, and after working the problem, you can continue to the video to see if your answer is correct. Alright? Example 3. It says, Aisha made a scale drawing of her bedroom using a scale of 0.5 centimeters equal 1 meter. The actual length of her room is 4.5 meters. What is the length of Aisha's bedroom on the scale drawing? Remember, always identify the key components of your question. So key components here, using a scale of 0.5 centimeters equal 1 meter. That's a key component. It tells us that the actual length of her bedroom, so now it gives us what? The actual length of her bedroom is 4.5 meters. So the actual length of her bedroom is 4.5 meters. What is the question asking us to do? What is the length of Aisha's bedroom on the scale drawing? So what is the length of Aisha's bedroom on the drawing? That's what we want to find. Alright? Remember, when we're solving, it is always the scale length over the actual length. So scale length over the actual length. So always remember that. Always scale length over actual length. Always scale length over actual length. Scale length over actual length. Alright. So remember, first step, the scale that is given in the question, we are going to set that as a ratio in fraction form, or write it as a ratio in fraction form. So first term goes in the numerator, second term goes in the denominator. That we're setting it as a proportion now. The question says that the actual length of her bedroom is 4.5. So the actual length of her bedroom is 4.5. Where does the actual go? Actual goes in the denominator. So 4.5 is going to go in the denominator. The question asks us to find what is the length of Aisha's bedroom on the scale drawing. So this time we want to find what is the scale length. Alright? Once we set our proportion, we cross multiply. If we want to test if our proportion is set properly, 0.5 is centimeter, 1 is meter, 4.5 is meter, so 4.5 goes in the denominator. So meters in the denominator. The scale length is what we want to find, so we know that our answer will, the unit of our answer will be in centimeters. So we go cross multiply, 1 multiplied by x and we have 0.5 multiplied by 4.5. Alright? 1 times x, that's going to give us 1x or x, that's the same thing. 0.5 multiplied by 4.5, that's going to give us 2.25. And it says 1x. So x, the coefficient of any variable that you don't see a number before the variable, we know that the coefficient is always 1. So, and the answer is in centimeters. Don't forget to write your units whenever you're solving a question. I hope you got that one correct. So 2.25 centimeters is the answer to that question. Alright, question 4. You can do the same thing here again. Pause the video, work the problem, and then continue to watch to see if your answer is correct. Example 4, and this is going to be our final question that we're going to work in this video. Miguel drew a scale drawing of a city. The scale of the drawing was 2 inches equal 10 yards. If the actual width of the neighborhood park is 70 yards, how wide is the park in the drawing? So how wide is the park in the drawing? Remember, identify your key components. It says what? 2 centimeters equal to 10 yards. That's the scale given. Alright? It tells us now if the actual width of the neighborhood park, is 70 yards. So the actual width of the neighborhood park is 70 yards. Question now, how wide? This is our question. How wide is the park in the drawing? In the drawing, that's very important. So remember, when we're solving, it is always the scale, length over the actual length. Scale length over actual length. Always scale length over the actual length. Alright? First thing, the scale that is given in the question, we're going to write it as a ratio in the fraction form. Alright? First term in the scale, we put it in our numerator. The second term goes in our denominator. So we have 2 over 10. We are going to write it as a proportion. It tells us that the actual width of the neighborhood park is 70 yards. Actual width is 70 yards. Where does actual go? Actual goes in the denominator. So 70 is going to be in our denominator. And the question asks us, how wide is the park in the drawing? In the drawing mean that is the scale drawing, so scale length. So the unknown will be in our numerator. Once we write it as a proportion, we cross multiply. So 10 multiplied by x, 2 multiplied by 70. 10 multiplied by x, that gives us 10x. 2 multiplied by 70, that's going to give us 140. Once the coefficient of the unknown is not 1, the aim is to always find what one of the x is equal to. Here we have 10 of the x is 140. So we want to find what one of the x would be equal to. Once it is not 1, we divide by the coefficient. So we are going to divide by 10. Ten into itself would go 1, 10 into 10 go 1. So that's cancelled. 10 into itself 1, 10 into 140 would go 14. X is equal to 14. And we are finding the scale, so this will be inches. Alright, so don't forget your unit. So x is equal to 14 inches. Alright, that will be it for this video. Thank you for watching. Remember to leave a comment and like the video. Alright.